Welcome to the 14th video in this video series of using Godot with the Writer IDE to create and modify a 3D mesh. In the last video, I was doing some cleanup on making sure that the two globals were properly being mapped for the normals, and that kind of that got some questions coming to me offline, and there was somebody in particular who was asking, how do you know when to use local and local versus global coordinates? Because when I was generating the wireframe mesh and the surface normals, the face normals, I wasn't doing any ToGlobal. So when I was generating the immediate geometry for the face, for the wireframe mesh, and for these face normals, I wasn't using global. And the question was, well, why is that? And if you look at the code when I was doing that, here's the draw wireframe, and you'll notice that I'm pulling out the vertices directly out of the cube mesh, and then I'm just adding them. I'm not doing any sort of ToGlobal here. It's just vertices I, because if you remember what we did in the last video, you'll notice that when we were we pulled stuff out of the mesh, but now we were doing this ToGlobal, and the question was, why are we doing ToGlobal when we're doing for the face selected check, but we're not doing the ToGlobal for drawing the wireframe of the surface normal? And I think one needs to kind of see where we're generating these immediate geometries, because if you run the game here, and then you look to see what's being generated, you'll notice that this is the cube mesh instance, that the wireframe immediate geometry and the face normals are children of the cube. And the thing to take notice of is that children inherit the transformations of their parent. So the way I kind of look at this is like when we were designing our cube here, we picked we were designing it in a local coordinate system. And if I'm going to pretend that rotations and scalings don't matter, we're just worrying about for translations, we had to come up with some coordinate system, because in order to map these different points of the cube, they have to be offset a certain distance from something, right? So we need some origin. Otherwise, how are we going to define that this is a cube shape? So when we're sitting at our desk drawing this cube, we're drawing it in the local coordinate system, and basically these points here are offsets of how far away from the origin these things are. And an interesting thing to note is that if you go to Godot, let's stop the game. So let's shut off the floor, and then you notice the cube. If you remember, we had to lift the cube up a little bit to put it above the floor, like 1.356 here. Let's just zero that out. So this is actually at the center of the world. And if you remember, we had to scale up the cube in a previous video, because the cube coming out of Blender that we were using originally was too wide, not TOO wide, the number 2 wide, 2 units wide. And when we generated our cube in code, it's only 1 wide, and we wanted it to be the same size, so we scaled up the cube mesh instance by 2. So let's get rid of that scaling, or at least comment it out for right now. So let's go down here, and here's where we're scaling it. Let's comment that out, and let's fire up Godot again, and just we should have a smaller cube and no floor. Smaller cube, no floor, but notice the normals and the wireframes are the wireframe is being drawn correctly. So something to take notice is, so when we designed our cube here, remember I mentioned that we had to, when we were using the local coordinate system, we were we had to somehow say how we were offsetting from that origin. And when this cube is placed in the world, it can be moved. And so it's no longer at the same place as the global, or the local and the global coordinate systems aren't the same anymore. But what we did in Godot here, since I zeroed this out and there's no rotations or anything else, no scales or rotations, this global placement of this cube is exactly the same as the local coordinate system. So what if we did something here? So what if when we drew the face normals, what if we, instead of, I guess FYI, so this script is on the main node. So just for the next step we're going to do here, just remember we're on the main node, and we have all these children under main. So if we're in the drawing the face normals, instead of adding the immediate geometry to the cube mesh instance, let's just add the child. And since the script is on main, it will add it as a child of whatever node the script is on. And we already said the script is on the main node. So let's also go to the draw wireframe code and do the same thing. So instead of attaching the immediate geometry to the cube mesh instance, we're just going to generate it, add it as a child of main. So let's run the game. Now we should notice no difference. It should look exactly as it did earlier. Okay. The face normals are there and the wire mesh is there. But if you notice now, the face normals immediate geometry and the wireframe immediate geometry are children of main. They're not children of the cube. And so why does that matter? Well, what if we in Godot, let's move this cube over, -5. What would you expect to be rendered here? Let's hit play and find out. Huh. Well, we're still getting the wireframe mesh, or wireframe immediate geometry, and we're still getting the face normals, but it's kind of a ghost. You know, it's the cube's over here, but these are over here. Why is that? Well, again, a child inherits the transformations from its parent. So in this case, this new placement that we've done, the wireframe and face normals, they're inheriting the transformations of their parent, which is main. Well, main is just the center of the world. So they're offsetted at the center of the world, and that's it. So when we move the cube, well, they're still centered at the center of the world, right? Because the only parent they're inheriting that from would be the main. So if we actually wanted to keep these here under main, and we wanted this to be drawn here, we would have to do the ToGlobal here. We would have to do the ToGlobal so that it would take the cube's transformations into effect. So if we go ahead back in our code and we make it so the cube mesh instance, the immediate geometry for the normals and the faces are now back under the cube mesh instance, then you know, when you run the game, you would expect everything to be rendered like it was before. And it is. So the way to kind of look at this, I mean, I was trying to figure out the way to answer the question for this person, because the question seems like it's an honest enough question. It's, well, how do you know when to use ToGlobal, and how do you know when to use the local? And I mean, I think the answer to that is it was easier for us to draw the wireframe and the face normals by just putting it underneath the cube, and then anything that was under the cube only had to be offsets of the its parent. So the way I kind of look at that is, so when we define this in our local coordinate system, the origin of our system was 0 in quotation marks. Well, when we put this under the cube, basically a way to look at that is pretend the new origin that this is defined, this is now the cube mesh instance, is 0, 0, 0. All the transformations, let's just pretend it's just translations. But scaling and rotation would be the same type of thing. But let's just translation's the easier thing to understand. Let's just pretend that this origin is where the cube center is. So once you put everything at the cube center, well, these offsets still apply. I think these are all 0.5 outs. 0.5 from the cube center, those still all apply. So that's the way local and global worked here. And so when we set this up, when we were defining the wireframe here, and we weren't doing any ToGlobals, well, we didn't need to. We just wanted to draw something that was kind of around the cube mesh. Now, we could have placed them underneath that main node, and then we'd have to ToGlobal everything, but why bother? If we can just stick it underneath the cube, and it inherits the transformation, so it's basically just an offset from that cube mesh instance, why not do it that way? I mean, that's a lot easier than having to do that ToGlobal. Well, so then the question is, well, when we did the get hit mesh triangle face index, why did we have to do a ToGlobal? Well, because there wasn't a common thing to stick this under like the cube mesh instance. I mean, what we were checking is we were checking the camera, where the camera was in space, let's be specific, where the cube was placed in space, and then we were checking, we were drawing that ray between the camera and where it was intersecting in space. Well, there wasn't any way to just kind of offset it from any particular common parent. We had to sit there and go, okay, in space, where's the camera? In space, where's the cube? That's not quite the same thing as when you're under the cube mesh instance and you're saying, I want to draw this thing that's going to be around this cube mesh. So I'm just going to put you as a child of the cube mesh and just give you the offsets of that. Same with the normals, by the way. I was mentioning the wireframe, but the face normals that we have are the same type of thing, where if you child it under the cube mesh instance, then you don't have to do any of that math. So I'm hoping that makes sense. I'm hoping that, this isn't it's more of like an intuition has to kick in inside your head and a light bulb go off so that you realize, what the difference is here. I mean, I don't know how well of a job I'm explaining here, or even how well I explained to the person who asked me the question, but hopefully that explains to you why when we set up the wireframe and the face normals, we didn't do a ToGlobal. I mean, we could have, and we saw how ugly that gets, so we could have, but I determined early in the series, let's not introduce global, local, like at the early part. Let's just get our feet wet on what we're doing. So just by making it a child of the cube mesh instance, I could kind of hand wave over that and go, let's just offset off the cube, no big deal. I mean, I don't even know when if they were watching this series sequentially, if it even occurred to them what we were doing here when we were defining the cube and then drawing the wireframe around it. I don't know if they actually, if anybody actually scratched their head at that time and was wondering what that was about. But I do know when I introduced the ToGlobal stuff with the face selection code, I know that sparked quite a bit of questions. So hopefully this answers enough where it's no longer a giant mystery. And I'm going to put this back to where it was. Turn the floor back on. Go back to writer. Go back to create and assign. Give me back that scale. So hopefully this is going to put it back to where it was before I started this video. And it did. So I think my next video is going to be the last video in the series. And I think what I'm going to do is I'm going to say when somebody clicks a triangle here, a face, I think what I'm going to have happen is once it's selected, if you hit the right mouse button, it's going to do a subdivide on that triangle. And I think that's going to, because in order to, what we're going to have to do behind the scenes is we're going to have to generate new geometry there. We're going to have to take that triangle, subdivide it, generate that geometry, and then put it back in a cube mesh instance. And I think by doing that, I think that fulfills what I wanted to do with this series, because the series was supposed to be about create and modifying a 3D mesh. Well, we created a 3D mesh several videos ago when we generated this cube in code. So now the modify, I think what I'm going to do is I'm going to have the triangle subdivide itself, and then subdivide, and then I think that will fulfill, that will give enough logic presented that if somebody wants to do something else, like maybe do an extrude, I mean, because when you do an extrude, you're going to take this face, you're going to pull it out via the face normal, then you have to generate the geometry of the sides. I mean, we could do that, but I kind of think that let's leave that up to the viewer to do. I think if I present the subdivide code, which honestly is going to be simpler than the extrude, because I think with the extrude you have to, there's a little bit more logic you have to consider there. But I think the subdivide will at least show the mechanics of how you would generate the new geometry and then stuff it back in the mesh instance so that things can be rendered correctly. So that's the next video. So I'm going to stop the video here and take care, and I'll talk to you soon. Bye-bye.